Hello everyone, today we're going to be talking about inverses of logarithmic functions. And for this first video, we're going to be talking about using inverse properties. So what we have is that the logarithmic function g of x is equal to log base b of x is the inverse of the exponential function b to the x. So in other words, g of f of x, which is equal to log base b of b to the x, is equal to x. And f of g of x is equal to b raised to the log base b of x, which is also equal to x. So essentially this means that exponential functions and logarithmic functions undo each other. So just like addition and subtraction are inverse, multiplying and dividing are inverses of each other, exponential and logs are also inverses of each other. So for instance, for log base b of b to the x, I see if I have that log b and that base b, right, by each other, those cancel each other out to just get that x. Same if I'm raising b to the log base b, those cancel each other out and I get just x. So let's look at some examples of using those inverse properties. Okay, so for each of these, I want to simplify. Number one, I have 10 raised to the log of 4. Here, we have to remember what log, when it's just written as log, what base that is. When it's just written as log, there's really an invisible base 10 right here. So here, since I have the same base, I have log, there's 10 raised to the log base 10. That cancels each other out, and this just becomes 4. Okay, let's look at number 2. So number 2, I have log base 5, 25 to the x. Right now I can't cancel those out because my b's are different. My log has a base of 5, where the base of this exponent is 25. So I want them both to be the same number. I want them both to be 5. However, I can recall that I can rewrite 25 to be 5 squared raised to the x power. And now I know from the power of a power property that I can write that as log base 5 of 5 to the 2x. And now I see that I have log 5 of 5. I know that ends up just being equal to 1, and that is because 5 raised to the first power is equal to 5, and so I end up with just 2x. Okay, number 3, I have 8 raised to the log base 8 of x. I see I have the same base of 8, so I know those are inverses of each other, so they cancel each other out, and I'm left with just x. Number 4, I have the natural log of e to the 3x. Remember, with natural log, that is the same thing as a log with base e. So I can think of this as saying log base e of e to the 3x. And so I see those are inverses of each other, and so that cancels out, and I'm left with just 3x. Same thing with number 5. Here I have e to the natural log of 10. The e and the natural log cancel each other out. They just equal 1. And so I end up with just 10. Okay, and then this last one, I have log base 2 of 8 to the x. So here I can't just say this is equal to x because I have 2 and I have 8. I have different bases, so those aren't inverses of each other. However, I can rewrite that 8 to be a base of 2. And I can do that by rewriting that 8 to be 2 cubed. And then I can use my power of a power property to say that this is equal to 2 to the 3x. And now I have my inverse there. Log base 2 of 2 is just equal to 1, and so I get that this is equal to 3x.